Which of the following sets has the greatest cardinality? The reals, the set of all functions from z to z, the set of all functions from R to 0, 1, the set of all finite subsets of R, and the set of all polynomials with coefficients in R. Okay, so I can certainly eliminate some of these options right away. The set of all functions from z to z. So okay, like the answer is not going to be A. It's not going to be the real numbers. I mean, okay, so let's just cross this out right away. Because the other sets have cardinality at least as large as R. B, functions from z to z. I would have thought this has the same cardinality as R. But let's come back to that one. Set of all functions from R to 0, 1. This is the same as the power set of R, is it not? The set of all functions from R to 0, 1. I mean, a function that maps R to 0, 1 can be identified with a subset of R, right? Any subset of R, well, for every number in R, it either contains, it's either in the subset or not. So it's either in the subset or not. And any function from R to 0, 1 can give us a subset. If at a point the function evaluates to 1, we put it in the subset, otherwise we give it 0. I mean, even just the notation for this typical type of thing, it's equal to this, so this is the power set of R. That might be the answer. Option D, the set of all finite subsets of R. So given that we have this identity, that this is essentially equivalent to the power set of R, this certainly can't be the answer, or at least the cardinality of this set is less than or equal to the cardinality of that set, because I mean, if we only look at finite subsets, those are of course all contained in the set of all subsets. And option E, the set of all polynomials with coefficients in R. How is that typically written? It's like something like this. So how is there a way for us to see that this is not the answer? I mean, this is essentially how do I? This is roughly equal. This is roughly equal to this one, right? If I give you a finite subset of R, I can create a polynomial out of that. If you give me a polynomial, I can create a finite subset of R. It's not an exact bijection the way you would naturally do this, because of course a finite subset of R, you know, the numbers are all unique, but the coefficients of a polynomial don't all have to be unique, but if I have a polynomial, I can give you a finite subset. And if I have a finite subset, I can give you a polynomial. But like, is one of these an injection or surjection or something like that? I guess this, if I take f, which maps a polynomial into, let's call this set f, like this, the way you naturally do it, just take the coefficients of this, throw that into a set, that'll be a finite subset of R. F is surjective. So surjective, that says that the cardinality of that is greater than the cardinality of that, greater than or equal to. I mean, I'm pretty sure the answer is C. Put it with a question mark there, simply because it's the only one with this R sort of up in the... Like, okay, put it this way. If I do the exact same thing, if I replace this with power set of R using the only sort of like the immediate way you do it, take all the coefficients, make a subset. This is definitely not surjective, but yeah, I mean, my intuition is just telling me like this is significantly smaller than that. This, I believe, has the same cardinality as the reals. This definitely has a greater cardinality than the reals, obviously. So, I mean, that's got to be the answer. I don't really have a great way of demonstrating or proving or something like that, but generally, I mean, I'll say common knowledge that these two have the same cardinality. I mean, we know that, for example, 2 to the n has the same cardinality as R. That's like the standard, kind of a standard construction or argument. And just because of, countability and stuff like that, I'm pretty sure these sets are the same size. Maybe I'm wrong about that. Maybe there is a, maybe this one is bigger than that. I'm not sure, but I'm pretty sure the answer here is going to be C. And I'd have to go, way back almost 20 years to refresh my memory on some of this stuff to see if I'm right or wrong. I will check my answer and I'll let you know if there's a mistake, but that's going to be my answer, C. Thanks for watching.